Good morning, grade 12s. Welcome to our technical mathematics. Today is the 12th of September, a very nice Saturday. Then I will be with you from now until 9 o'clock. As you can see on the screen that today we'll be looking at Euclidean geometry. This is the topic that we'll be dealing with for today's lesson. I hope that you will be able to join the lesson for this Saturday. Because this lesson is going to be very interesting. And then now, before we can start into our business for today, I just want to advise my dear learners that please make sure that you do have your examination guideline. It's a very important document that a learner should have. And then, especially for this topic that we'll be dealing with today's lesson, it shows the important information that one should know before you go and write your examination, especially when it comes to the theorems under Euclidean geometry for grade 11 and grade 12. And then the other important from that document is reasons that we're using when we are answering the questions under Euclidean geometry. Remember, when you answer any question under Euclidean geometry, you have to reason at all times. Now, there are acceptable reasons that a learner should use in examination or while the learner is writing exam. So it's very important to have that document. And then for those who don't know where to get the document, you can just go to Google and then type technical mathematics examination guideline, and then you will be looking for the DBE website. Then you just click there and then look for that document. It's a very important document, like I've indicated. All right. Now I think we can now start our lesson. We can start our lesson. I think we have one person here, which is Kabiso. All right, I don't see Kabiso again. All right, I think we can now start our lesson for today. All right, under content for Euclidean geometry, you can see that this topic is divided into two, mainly the grade 11s Euclidean geometry, as well as the similarity and proportionality theorem for grade 12. And then this topic, as it is, it contributes 40 plus or minus 3 marks for paper 2. For paper 2 is very important. And then under Euclidean for grade 11, the important things a learner should know when dealing with those theorems. One, you must be able to state the theorem in words. It's very important. Each learner should now to be able to state the theorem in words, and then apply the theorem to solve the writers and give the correct acceptable reason. Now, if a learner didn't know on how to state theorems, then it's going to be very difficult for that particular learner to be able to answer questions or to solve writers, because it's very important to know. Remember, we've got 9 theorems for grade 11, and then you must be able to state all those theorems so that by the time you engage to questions, then it's going to be easy to remember which theorem you are dealing with, right? So it's very important to revise them, and even to know even the structure of each theorem, right? Then in that way, I believe that you'll be able to cope when it comes to solving any problem under riders, and as well as the acceptable reason. I also need to emphasize on this issue of presence because it's very important. Like I've indicated earlier on about the examination guideline, that it outlines the acceptable reasons that learner can use during exam. All right. So it's very important document. You can just go and try to revise before you go and write your second paper, which is paper 2 for this trial exam, and then also prepare yourself for the final examination. Now let's get into our business for today and see what we are having under Euclidean geometry. All right. Then we'll be looking at the theorems, and then we're going to be stating those theorems. So we are going to remind ourselves, because it's very important, my dear learners, to remember every theorem, how to state it is very important. Like I've also alluded that by the time you're going to solve riders, then it's going to be easy for you, because now you'll be knowing all those theorems on how to state them, right? Now, first we are going to be completing the following theorem. Number 1, the angle subtended by the diameter, at the circumference of the circle is, then you have to complete. And these questions, they normally ask them during exam, where you have to complete the sentence, right? So hence I'm saying, please make sure that you go and read all the theorems and then try to be able to state them, right? Now let's see on how do we get the answer for this one, where it says the angle subtended by the diameter at the circumference of the circle is 90 degrees. Meaning when you have a diameter and then the angle subtended by that particular diameter, then it's going to form an angle of 90 degrees, all right? So hence they are saying the angle subtended, the angle formed by that diameter, is equals to 90 degrees. Then number 2, the exterior angle of a cyclic quadrilateral is equals to, the exterior angle of a cyclic quadrilateral is equals to what? Is equals to opposite interior angle. Opposite interior angle. So every time when you read this, in your mind, you must picture that diagram. You must have that picture in your head or in your mind about that diagram. So that shows that you know each theorem. Number 3, a line drawn from the center of a circle to the midpoint of a chord is to the chord. Is what? Is perpendicular. A line drawn from center of a circle to the midpoint of a chord is perpendicular to the chord, right? And it also bisects that chord. If you remember theorem 1, this is theorem 1. A line drawn from center of a circle to the midpoint of the chord is perpendicular to a chord, right? And then number 4, angle angles opposite equal side in the isosceles are equal. Angles opposite to equal side in isosceles triangle are equal. So all those angles are equal, right? All the two, I think it's two angles that are equal in isosceles, right? Number 5, opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quad, they add 280, meaning supplementary. The opposite angle of a cyclic quad are supplementary, right? And then number 6, the tangent of a circle is the radius of the circle at the point of contact. Now our answer is the tangent of a circle is perpendicular to the radius of a circle at the point of contact. Number 7, the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. The angle between the tangent to a circle and chord from the point of contact is equals to the angle in the alternate segment. So those are theorems that we're having, but remember we have got 9 theorems, meaning we are only left with 2. We have left with 2 because in your screen we're having only 7, so we are left with 2. So, but please go and revise all those theorems and be able to state them. So it's very important, my dear learners. Now let's proceed and see what we're having. Now we're having one example under Euclidean geometry, and let's see. All right. Now we are going to be solving the riders, but still bear on mind that we are going to be using what? All the theorems that we have learned, right? So if, for instance, when you look at this picture here, you must be able to see the theorems which are involved on this one. So if that is the case, then it shows that you have revised them, you understand them, then it's going to be easy for you to answer the question. Now let's see what we're having on this one. It says in the diagram below, O is a center. We can all see the center there of a circle, PMST. Where is P? This is PMST. Those are the point on the circumference of a circle. And then RS, where is RS? RS, I think, is a tangent at S, right? And angle S1 equals to 56, and then angle O1 equals to 104 degrees. Now, my dear learners, every time when you read a scenario under Euclidean geometry, and then, for instance, for this one, you can see that they are talking about the tangent, right? Then when they talk about the tangent, all the theorems that are talking about the tangent, one of the theorem is going to be applied here. So we're going to apply that one, right? They cannot just give you a tangent and then they're not going to ask anything with regard to the theorems that talk about the tangent. All right. So when you, on your side, you must be able to record all the theorems that talk about the tangent. So it's very important. And then also the center, we've got a center there. Which theorems that have a center? We've got only 3 theorems that speaks about the center, if you remember very well. Theorem 1, Theorem 2, Theorem 3. Theorem 1 is that theorem that says a line drawn from center to the second is perpendicular to a chord and bisect a chord. And the other one is that one of angle at center is twice the angle at circumference. And the last one is when we are having one diameter. You remember earlier on we talked about diameter. Angle subtended by that diameter is equal to 90 degrees, right? So surely one of these angle, a theorem is going to ask, or we are going to use that theorem to help us to answer the questions. All right, you cannot just get a center and then you don't touch one of these theorems. All right, the same applies with what? With tangent. They cannot just give you a tangent and then they are not going to give you anything about theorem that speaks about the tangent. So make sure when you read the scenario, you underline such things. The center, when you have a center, think about it. When you have a tangent, it means for this one, we're having what? We're having two theorems. Actually, not theorem, but the groups of theorem. Only two groups. Remember, we've got three groups. One, the first group is that group of having a center. The second group is cyclic quad. And the third group is a group of theorems that has tangent, right? Now, let's try to answer the following question. Say, determine and state the reason the size of the following angles. Angle S2, let's go and see angle S2 is this one here. And let's see on how do we answer that question. Then we say angle S2 equals to 90 minus 50, 56 tan perpendicular to radius. Then we all know that if we have a radius, a line from center is always perpendicular to what? To tangent, meaning where they meet, they form 90 degrees. So this angle here is 90 degrees. Then, of course, we've got an angle already for angle S1 there, which is 56. Then we're going to be saying 90 minus 56, then it's going to give us this angle here, which is angle S2. And that angle is 34 degrees. All right. And that I don't think we've got another way of getting that angle there. I don't think we've got another way of getting that angle there. All right. Now, the next question says, P angle MS. Let's go and look for that angle. P angle MS, meaning they are referring to this angle here, angle M1 plus angle M2. So what is the size of that angle? Let's see. They are saying angle P angle MS equals to 90. Angle in the same segment. You remember we've got what? We've got diameter. And then we said that the diameter or the angle subtended by diameter is equals to 90 degrees, right? So once we have a diameter there, the angle that is going to be formed by this diameter then is going to be 90 degrees, right? So you can give this reason that says angle in a semicircle, right? Angle in a semicircle. Next question, angle P. Let's go and look for angle P, meaning we are in need of this angle here. We are in need of this angle there. Let's see. Yes. Now, because remember PMS is a triangle, and then already we have determined angle S2. And we have also determined this angle M, right? Now we know that the sum of the sum of angles of a triangle, they add up to 180, or they are supplementary. Now, hence we said 180 minus the sum of the other two angles, then it's going to give us 56 degrees, meaning this angle here is 56 degrees. If you add this one plus this one, and then you minus them from 180, then it's going to give you 56 degrees. So that is the angle of angle P. The last question says determine what? Angle M1. Let's go and look for angle M1. Let me just remove this one now. Let me just remove this one. Now you remember earlier on we've determined this, the whole angle, which is angle M. But now they're only interested on this angle there. Let me just show you. Let me just remove that one. All right, let me remove it. Now we want angle M1. We want angle M1 there. Let's see. How do we determine angle M1? All right, of course. Now, angle M2. Then first we are going to determine angle M2. We can see that this angle here at center, which is 104, is twice this angle M2. Then hence we have had to divide with 2 to get the half of that angle, which is 52 degrees. And then the reason, of course, is angle at center is equals to 2 times the angle at circumference. All right, but we haven't answered the question. Remember, we are looking for angle M, angle M1. All right. And then we said angle M1 plus angle M2 is equals to 90. Remember, we have indicated, I mean, we have solved that earlier on, that angle M equals to 90, right? And then since we have determined angle M2, then it's going to be easy for us to determine the angle M1. Then we're just going to transpose that 52 to the right hand side so that we can minus from 90 there. Then our angle now is equals to 38 degrees. Our angle is now 38 degrees. So that was for this cycle, our rider. Then we can just proceed. All right, let's see what we're having. We're having another cycle there. And then let's see on how do we answer this one. In the diagram below, PQ is the diameter. Let's go and see where is our PQ. Okay, we can see Q is there and then P is there, is the diameter. The diameter. So every time you can see on this one, we are having a diameter. So we must always remember the diameter, the theorem that speaks about diameter. It's very important. Of a circle, PQRS. PQRS, these are 4 points. These are 4 points on the circumference. And then TS is the tangent to a circle at point S. Point S. Let's see point S. You can see the tangent is there, and then is the tangent. All right, and then angle S1, which is 38 degrees, and angle P1 equals to 17 degrees. Determine with reason the following. Angle R2, let's go and look for angle R2. This angle R2. Then let's see on how do we answer that. Of course, angle R2 is going to be equals to 38, because now remember, when you have what? A tangent and a chord, and then this angle here is equals to the angle there, right? So they are equal. So the reason for that is tan chord, right? In short, you can just write tan chord. And then yes, we have answered that question of angle R2, which is 38 degrees. And then number 2, we have angle M1. Let's go and look for M1. All right, this is M1. Okay, then let's go. And then we just say angle M1 equals to 38 times 2. Yes, why? Because you can see that this, let me just try to show you this. I think this is theorem 2. You can see the structure. This is theorem 2, and we're having this, we're having that, and then as well as this side. You can see this side, meaning this angle here is twice this angle there, right? But this time we have determined an angle R2, then meaning hence we are saying this angle is times 2, then it's going to give us angle M1. Then hence we said that 38 times 2. Then the reason for that is angle at center is twice the angle at circumference. All right. Then our answer is 76 degrees. And then number 3, we have angle S2. Let's go and look for angle S2. Yes, is this one. Angle S2. Then you should remember about the radius, the relationship between the radius and the tangent there, right? They are perpendicular to each other, and then where they meet, they form 90 degrees, and then from 90 we have this 38 degrees. Then we don't know what is going to be our angle S2 then. Then we're just going to subtract what? 90 minus 30, 38 degrees. And what is the reason for that? Tan perpendicular to radius. And then our answer for angle S2 is 52 degrees. So that is our answer. And then let's go and answer for number 4, angle Q2. Let's go and look for angle Q2. Let me just erase this pen here. All right. Angle Q2. Angle Q2 is this one. And let's see on how do you answer that one. Then let us agree on this one, that angle P2 is equals to angle Q2. What is the reason? Angle opposite equal side, right? Let me check. Is that so? Angle. Let me check angle S. All right. No. I'm referring to the wrong one. Now we are looking for angle P. Yes, it is angle P here. The whole angle here is equals to angle S, right? Why? Because PM equals to MS, right? PM equals to MS. Remember isosceles, and then this angle, they are equal, and then that angle of angle P equals to, is also equals to 52 degrees, right? Then we're going to say, now since we have got angle P1, which is equals to 17 degrees, and then we can be able to determine what? Angle P2, because now we are having the whole angle for angle P. Hence we say angle P2 equals to 52 degrees minus 17 degrees, right? Then it's going to give us what? 35 degrees. So that is for this angle here, right? And then I also touched on this one to say angle P2 is equals to angle Q2, right? What is the reason? Arc RS subtend equal angles. this arc here. I'm referring to this arc there. This arc is subtend equal angles. If you don't want to say arc, you can say chord. Chord SR subtend equal angles, right? You can say chord SR, or you can say arc SR subtend equal angles, all right? Or you can say angles in the same segment. Angle in the same segment. And therefore, we've now determined what angle R2, which is 50. We've got another one. Let's see on this one. The diagram below shows a cycle GWTH. Where is that? You can see this is GWTH with a center N. Now we're having a center. So once you've got a center, you must think about three theorems. The first theorem, the second theorem, the third one, right? And then GT is the diameter. Think about the diameter as well of the circle. Then G angle NH equals to 68 degrees, and angle T1 equals to 38 degrees. Now let's answer the questions. Determine, state with reasons, the size of angle W1, which this angle, that means we're in need of this angle. Then, but you can see for that angle to be determined, then you have this structure here. You remember theorem 2, angle at center is twice the angle at circumference, and already you've got angle here which is 68 degrees. And let's see how do we do that. Then yes, 68 divided by 2. Raising angle at center is equals to 2 times angle at circumference. Okay, and therefore then we have our answer there is 34 degrees. Our answer is 34 degrees. All right. And then number 2, give reasons why angle H1, this angle here, and is equals to angle T2. Why those two angles are equal is because what? It's because NT is equals to NH isosceles. So which is angles opposite equal sides are equal. Angles opposite equal side are equal. So meaning those angles, they are equal, right? So we know that when we are having two sides which are equal, then the opposite angle of those two sides, they are also equal. Number 3, hence determine, state with reason, the size of angle H2. Let's go and look for angle H2. Let me just erase this pen. All right. Then we're looking for this angle here. We're looking for that angle, and let's see on how do we do that. Now, for you to be able to get that angle, I think you still remember about a line drawn from center to what? To the chord of the circle. What is happening there? They are always perpendicular there, and then of course this is going to be 90 degrees there, right? Once you see a line drawn from center, it will always be perpendicular to the chord of the second. All right. Therefore, since we have got 90 there, and we've got this angle of 68 degrees, then we can be able to determine this angle by adding the sum of interior triangle. And hence we set 180 minus into the two angles, then our angle at H2 there is 22 degrees. 22 degrees. So that was that for this question. And can proceed and see what we can have next. Right. All right. In the diagram below, AB, you can see the chord of a circle with the center O. D is a point of a circle. OD is perpendicular to AB. Yes, and then OA is equals to 25 centimeter, and CD equals to 18 centimeter. All right. And then calculate with reason the length of AB. Then we are looking for that length there. Then we can see that we are having this angle, this side, this length, which is the radius, is 25 there. This is 25. All right. And then we also have what? CD. Where is CD? This is CD. This is CD, which is 18. Right? This is 18. Then we all know that OD is also a what? It's also radius. And then AO is what? It's radius. And then OB is what? It's a radius. But now look at this one, OD. We only have what? 18 from C to D. Then we don't know what is left there. But because we know that the total length of radius is equals to 25, then it's going to be easy for us to answer that question. Then we're going to determine that OC by saying OC equals to what? OD minus DC, which is 25 minus 18, then it's going to give us what? This angle here. Then we're going to determine this angle here, because we really need this angle so that we can now focus on this triangle AOC, right? This triangle AOC, so that we can be able to apply or use the theorem of Pythagoras to calculate the side, and then we can be able to answer that question that needs the length of AB. All right. Then since we've got two sides on this right angle triangle, because it's a right angle triangle, then we are using the theorem of Pythagoras to determine the length of AC first. Then this is the formula, and then the next step, just substitute, and then because now we are looking for AC, then we're going to transpose. Then we can see that 25 squared is 625, and then 7 squared is 49. And then because we are looking for the length of AC, then we have to get rid of this exponent 2, and then we're going to put square root both sides. Then the length of AC is what? 4 centimeter, right? But of course, we know that this is theorem 1. If a line drawn from center is perpendicular to a chord and bisect a chord, meaning the distance AC is equals to the distance CB. And let's see that, yes, AC equals to what? CB. Okay. Now, since we've determined AC, then we can just say AB equals to AC plus CB. Then it's 24 plus 24, which is equal to 48 centimeters. So that is the answer for this question. Then we can just proceed. All right, now we are having a new question. Let's look into this question. In the figure below, ST is perpendicular to QW. Let's see, ST is this one. You can see ST is this line, is perpendicular, I think it's parallel. Actually, it's parallel per se. It's parallel to QW, all right. And then JQK is a tangent to a circle, and then angle W1 equals to 41 degrees, and then angle Q3 equals to 64 degrees. All right, now before we can answer the questions, now you can see that from the scenario we're having two sides which are parallel to each other. And every time when you are having parallel side, you must always think about the alternate angles, corresponding angles, or co-interior angles. So you not be having parallel lines if one of those things they're not going to apply, right? Meaning if you just have two sides which are parallel, surely there are some angles which are alternating, corresponding, or the last one. So we have to make sure that we look into that. And we also have a tangent. Remember, I also touched on the tangent there. If you have a tangent, the reason why we have to have a tangent, we've got only three theorem that speaks about tangent, right? So one of the theorem is going to be applied on this one. So it's going to help us a lot. But let's see what we have to answer on this one. Determine the size of the following angles. Angle S1, let's go and look for angle S1. Let me just erase this pen here. All right, this one, and this one, and this one. And then we're looking for this angle S1 there, all right? And then, now since this angle is part of this side, which is parallel to this one, and then it's obvious that this is equals to this one, the alternate angle. Let's see, that is true, yes. Angle S1 equals to 41 degrees with alternate angles. The alternate angles are equal, right? And then angle V, this angle here, we're looking for this angle. Let's see on how do we determine that. And then we set angle V equals to 180 minus 1. Why? Then we can see that STVW, those are 4 points on the circumference of a circle. Therefore, this what is a cyclic quad, right? And then we also touched about the opposite angles of a cyclic quad earlier on, because you can see this angle S1 is opposite to this angle D, right? So we know they are supplementary. Hence, we've indicated that 180 minus 41. Then the reason for that is opposite angles of a cyclic quad, right? And the answer there is 139 degrees. And the last question, which is angle S2. Let's go and look for angle S2, which is this angle here. We are referring to this angle there. Let me just erase this and this one and this one. Now let's try to answer this question. Angle S, all right, angle S2. Then how do we answer that? Then you can see, then we're having a tangent. Yes, angle S2 equals to 64 degrees. And then what is the reason? Tan chord. The reason is tan chord. I think that was the last question. And it was very interesting questions. So we can just proceed. Okay, then we are having another question, a new question. It says the diagram below shows a cycle A, B, C, D. Let's see, A, B, C, D. Those are 4 points on the circumference of a circle. And then of course we've got what chord BC, where is chord BC, BC, chord BC, and then and AD, AD. And you see that BC and AD produced and meet at E, right? And therefore angle A2 equals to 23 degrees. You can see there. And the angle C1 is 53 degrees. And then the last one, angle C3 equals to 56 degrees. Now let's answer the following question. You should determine and state reasons, the size of the following angle, angle A1. Let's go and look for that, angle A1. We need this angle here. And let's check on how do we answer that. Yes, angle, this angle, which is angle A1 plus angle A2 is equal to this angle S3. What is the reason for that? Exterior angle of a cyclic quad, right? Exterior angle of a cyclic quad. Now, but because we are having angle A2, then we also have angle C3, then it's going to be possible for us to calculate this angle A1. Let's see. Yes, what we did, we just put angle S3, which is 56 degrees, and then we transpose this angle, which is 23 degrees. Then now it gives us that angle of angle A1 is 33 degrees. Okay, and then now we move to angle B2. Angle B2, which is this one. Angle B2 is this one here. Yes, and then of course angle B2 is equals to angle A2. Only A2, not the whole A, but only this portion here, which is, let me just show you, if we can just remove this one. All right, now this angle A2 is equals to angle B2. What is the reason? Angle in the same segment, right? So if you don't want to give that reason, you can now say arc CD sub 10 equal angles, or you can say chord CD sub 10 equal angles. So either one, then it's also fine. Then we have just determined that angle, which is angle B2, which is 23 degrees. And then the last question is we have to determine angle B1. angle B1. Let me clean this one and this one, and then let's go and look for angle B1. All right, our angle B1 is this one here, and then let's see on how do we do that, and then we can agree that angle B1 is also equals to angle C, what? Angle C2, right? Why? Because chord AD subtend equal angles, right? Or angles in the same segment, right? Now, you can see that it's possible for us to determine angle C2 because this angle is part of these two other angles, and then they are on a straight line. Then we know that angle on a straight line. How do we determine that? Then we can see that we've determined the angle C2, which is 180 minus 53 minus 56. Angle in the angle on the straight line. Angle on the straight line, they are supplementary. And then the angle S2 is equals to 71 degrees. Therefore, then our angle B1 equals to 71 degrees as well. So that was that. It was also interesting question. So hence I am saying, learners, that it's important to know all the theorems. Once you have studied all the theorems, then everything is going to be possible for you. You can be able to cope in any question because you just apply the theorems here. There's nothing new that we are applying. Now, I think we're done with the grade 11 Euclidean geometry. And then now we'll be touching on what? On the similarity and proportionality theorem for grade 12. Remember this one we have dealt with in grade 12. It was introduced to you in grade 12. So then we'll be looking at this one as well. This is very important. And then let's see. A line drawn parallel to one side of a triangle divides the other two sides proportionally. A line drawn parallel to, now let's have that picture there. A line drawn parallel to one side of a triangle divides the other two sides proportionally. You can see that there's a line which is line DE, right? Now remember, previously we had what? We had the triangle ABC, right? Now when we have to now draw a line which is DE, which is parallel to the other side, which is BC. Then what is going to happen? Then it divides that triangle. It divides the other two sides proportional, meaning this side 1 and side 2. Let me just label like that. Then it divides this other two sides proportional. Now let us understand how. Let's see. Therefore, the ratio is then is going to be this. Then you can see AD. Let's go and look for AD. This is AD. You can see that you're having AD divided by DB, right? Then you can see on the left-hand side the way we have moved. Then we also have to move exactly the same on the right-hand side. Then it's going to be AE, because we cannot say AC. On the left-hand side, we did not move that way. We said AD divided by DB. So I must also do the same on this side to say AE divided by EC. Then that's what you are having. And then every time once you state or write that or those ratios, then you must always state this reason that say line parallel to one side of a triangle, right? So this is the acceptable way of writing that the reason for this particular thing. Instead of writing the whole sentence, you can see the whole sentence. So in exam, you cannot write a line drawn parallel to one side of a triangle divides. No, we can use this one. Hence, I was emphasizing on the issue of getting the examination guideline, because it outlines the way in which we can write the theorems in short, right? So please go and look for that. Boys and girls, go and look for that. It's very important document. Then I will always remind you and always encourage you to get that, because it's very important. It's going to help you a lot before you go and write your exam. Now, you can do that again. You can now see that we have another way of writing it. AB, let's go and look for AB. And this is going to be AB, all right, divided by AD. Can you see that? AD. All right, I think it will be much better if I can just remove the previous one so that you can be able to see which one are we talking about or are we referring to. Now, we first said AB, now divide by AD, right? We can see the way we have moved on the left-hand side. You must also do the same on this side to say A, what? AC divided by AE, right? Then immediately after writing that, you write the reason that say line parallel to one side of a triangle, always. So don't forget that, right? And then you can also do the same. We can now see that AB, where is AB? It's still the same AB, but by DB. So the way you've moved, remember, you must also do the same on the other side. So it's very important, my dear learners, to understand this one. Meaning, only if a triangle has what? Has a line parallel to one side of that triangle, then you are going to apply what we are doing right now, right? Because we know that, or it's proven that if that is the case, if two sides they are parallel, then the triangle divides the other two sides proportionally. So proportionally meaning those ratios are equal. So the ratio of this side is equal to the ratio of the other side. So it's very important. All right. Now I think from here we are going to be answering questions, and then we're going to apply what we are talking about right now. Okay, let's go and do that. All right, now let's proceed. Now let's get example 1. All right. In the figure below, triangle PQR has TM parallel to QR, and then PQ equals to 28 millimeter, and then the ratio of PM and S2MR is 4:3, right? Now let's just indicate here the ratio, the PM. This is PM there, and then we have MR, and this is 4. This is 4. Then I will write what? I will write 4K there. I will write 4K because remember, when we are referring to a ratio, it's not a distance. Ratio is not a distance, people. It's not actual distance. Hence, we had to what? I had to put K next to this 4 to show that this is a ratio, but it's not what? It's not actual distance. It's not the same as this one of PQ. You can see that the actual distance for PQ is 28 millimeter, right? But remember, on this one, we are using the ratios in order to be able to calculate the actual distance of any side, right? Then, but today we'll be learning on how can we use the ratio to calculate the actual distance, okay? Now, from the scenario, we know that, we are having TM is parallel to QR. And then every time when you come across that, it tells us that the ratio of this left hand side is equals to the ratio of this side, which is PMR, right? Then we can be able to answer any question. Now, the first question says we should now determine the length of TM. Where is TM? Let's go and look for TM. Oh, this is TM. No, actually, it's not TM, but it's TQ. Sorry for that. It's TQ. Okay. Now we are looking for this length there. Let me try to write it. Yes. All right. Now we are looking for that length, right? Now, just advise my dear learners, when you answer this question, now every time you must start with what we are in need of. What we are calculating, you always start with it, right? Then we can see from the scenario is what we did, right? Then we said TQ. We have started with TQ because that's what we are looking for. We are looking for TQ, the length of TQ, and then divide by what? Divide by the side which is having the actual distance. Now we can see the side that has the actual distance is PQ, right? Now we can see that we have the way we have moved on the left hand side. We said TQ divided by PQ, right? Can you see that? This is the way we have moved. We said what? TQ divided by PQ. So the same applies on the side. Then we're going to say MR divided by PR. And then we can see that MR is 3K, and then PR is what? Is 7, because it's going to be 7 plus this 3. It's going to give us 7K. Then we're going to substitute there, and then MR is 4. MR is not supposed to be 4. The mistake there. MR is 3. Then it's supposed to be 3 here. Let me just erase this one. Please forgive me. I think it was just a mistake there. It's supposed to be 3 there. Divide by what? Divide by 7, not 3. Then we're going to redo this one. Don't worry, we're going to redo it. And therefore, and then after this, then we're going to do cross multiply. Now let's do cross multiply. Then it's not going to be multiplied by 3, but it's going to be multiplied by what? By 7 on this one. And this one is 28 multiplied by what? 28 multiplied by 3. It's 28 multiplied by 3. All right, now let's calculate. Let's calculate that, my dear learners. And then if we say 28 times 3, it gives us 84. Then let's cancel this one here. Then it's going to be 84. And let me just remove this and try to write 84. This is going to be 84. 84 divide by what? Divide by 7. Remember, it's no longer 3, but it's 7. Divide by 7. Now let us try to divide that. 84 divided by 7. It gives us what? It gives us 12. So the correct answer for this one is 12. Is 12 millimeter. 12 millimeter. I hope we can be able to see the mistake that we committed there, and then we try to rectify that mistake. All right, now I think it's going to make sense now. All right, that is that. So we've answered the question. So the actual distance actually is now 12 millimeter, right? It's 12 millimeter. And then we have canceled this one. It's not correct. All right. Now example 2. Right, example 2, we are having what? Let's see what we are having. In the diagram, triangle M and P. Where is M and P? M and P. Can you see that? Triangle M and P with R on MP and T on MN is given such that RT is parallel to PN. S is a point on a PN such that TS is parallel to MP. And then, of course, we are having what? We're having MR, which is equals to 10 units. RP is 4 units. MT is 8 units. RT is 9 units. TN is X unit. And the last one, we are having SN, which is equals to Y unit. Now, the first question, it says calculate and state the numerical value of X. Meaning we need to know the value of X. We need to know the value of X. Then we can, it's very clear that we are having two sides which are parallel. RT is parallel to PN. And if that is the case, then we know that the ratio of this side is equals to the ratio of this side. All right. Then I also touched on this issue that say we always start with the side that we are looking for. In this case, we're going to start with Tn. We're going to be starting with what? Tn. Then what we can do, we're going to say Tn divided by Tm, because Tm is, we're having actual distance, which is 8 units, right? So let's see if that is the case. Yes, we said Tn, we have started with Tn, and then we have Tm. We have Tm, and the way we have moved on the right hand side, we must also do the same on the left hand side. So it's going to be PR. Is that so? Yes, it's PR. You can write it RP, it's fine. And then also RM, you can say RM. Then that's what we, and then I said that immediately after writing this ratio that they are equal in this manner, then don't forget to write the reason line parallel to one side of a triangle. Of course, then this is what? X, and then this is 8, and then this is 4, yes, this is 10. So everything is fine. Then you just do cross multiply. Then after cross multiply, you're going to divide. You can see that 8 times 4 is 16, right? No, not 16. Let me check, because now our answer is now simplified already. So we can just say 8 times 4, which is 32, and then 32 divided by 10, then it gives us 16 over 5, then which is equals to 3,2 units, right? So that's how you should get that answer. So it was quite simple and easy, and we just applied with what we have learned earlier on when we were referring to the ratios. All right, the question is still continue. We still continue the question. All right, now don't forget that we have determined this value of X. We have determined which was 3,2. All right. Calculate this and state the reason the numerical value of Y. We are now looking for Y. Then you agree with me that we also have another triangle which is NPM, and then TS. You can see this TS is parallel to this side of MP, meaning this side is equals to this side in terms of ratios, right? They are equal. Then it's going to be possible for us to calculate what? To calculate the value of Y. The value of Y. Let's see on how do we do that. Now, of course, we said that PS is equals to RT, which is 9. Why? Because PRTS is a parallelogram, and we know that opposite side of a parallelogram, they are equal. They are parallel as well, they are equal, right? And then that's why we are having now PSS 9 units, right? We are having PSS 9 units. Then you can see it's only Y, which is unknown, because we earlier on we have determined the value of X. We have determined the value of X on this one, right? And then now what we can do, let's see how do we do that. All right, remember I said that we must start with the side that we are looking for, which is N. In this case, you can see it's NS, right? It's NS. And then let's see NS. Let's see NS. Started with NS. We started with what we are in need of. Divide by what? PS, then equals to NT, and then the last one is MT, right? Then let's see. Then we just substitute, then you're going to cross multiply. All right, let's cross multiply. Then you can see that when you say 9 multiplied by what? 9 multiplied by 3,2, it gives us 28,8. Then you divide with 8, then it's going to give us what? It's going to give us 36. I'm not 36 per se, but 3,6 units, right? 3,6 units. So that's we determine that value of Y. So that was that. Okay, the question is still continue. And now, hence show with calculation that triangle MRT is similar. This sign means similar to triangle TSN. So we're going to prove these two triangle, they are similar, right? Let's see. Okay, now first we are going to be proving that with what? With ratios, proportional side, and then we set RT. Where's RT? This is RT, which is 9. RT divided by NS. RT divided by NS. And then it's 9 divided by 3,6. Remember, we've determined Y 3,6. Then you give us what? 2,5. And then we say TM. T 3,2, 2,5. And of course, MR is 10 and TS is 4. TS is 4. And then you give us 2,5. Of these two triangles, they are equal, the ratio. Then it tells us that those two triangles, they are similar, but all are equal. So there are two ways you can use, you can prove two triangles, they are similar using angles or sides, right? And then also this one, you can prove it by using what? By using the angles. For instance, we can see that let me just say this angle here, angle N, is equals to angle T. What is the reason? Corresponding angles, because RT is parallel to PN. That is the first one. So we have just proved that this angle here is equals to this angle here, right? And the other angle, I think this angle is equals to this one, corresponding angles as well, because this is parallel to this. But this angle P is equals to angle R, right? It's equal to angle R, and therefore, if that is the case, therefore this angle R is also equals to angle S. Meaning we have proven that this angle is equals to this one. Of course, the third angle must be equals to this one now. Can you see that? So meaning you can also prove these two triangles, they are similar when we are working with what? With angles. But as we just proved it with what? With ratios, that you can see they are equal, meaning those two triangles, they are similar. And then all the corresponding sides are in the same proportion. You can see that all the corresponding sides are in the same proportion. Therefore, triangle MRT is similar to triangle TSN. Okay. Then we are having example 3. Let's see what we're having. Example 3. All right. In the diagram below, triangle PQR is drawn with S on PQ, T and V on PR, and W on QR, such that ST is parallel to QR and VW is parallel to PQ. Furthermore, the ratio of PS is to SQ is 1:3. And then RW is 4 units, whereas QW is equals to 5 units. And but I think we'll be answering that question. The first question says determine the with reason the length of TR. Let's go and look for TR. TR is this one here. TR is this one. We are looking for that. And then we can see from the scenario we're having the ratio, which is PS. This is PS, and this is PS is 1. Then let me just write 1K there, and then SQ, which is 3. SQ, which is 3. It's going to be 3K. This is 3K there. It's 3K, yes. Now, that is the information that we're having. All right. All right, now let's see on how can we determine that. Now, we said TR, and then divide by TP is equals to SQ divided by SP. Why? Because we can clearly see that we have ST, which is parallel to QR. So meaning that this side is equals to this side in terms of ratio. And don't forget to write the resin line parallel to one side of a triangle. Second step, we substitute. And remember, I said we start with what we're in need of, which is TR. Then we're going to do cross multiply.
Then let's do cross multiply. Then the answer is 9 units, meaning the length of TR is 9 units. Okay, and then to express VR, where's VR? This is VR. This is VR. Let me just try to clean, and let me clean this one. All right. They say we should express VR in terms of X. How do we do that? Now, remember we have determined the length of TR, which is 9 units. Now, to get this side, we can say 9 minus X, so that we can get the length of VR. But now it's going to be in terms of what? It's going to be in terms of X. Then you can see that is the answer. So it's 9 minus X, right? And the third question, give the numerical value of RV. Where's RV? RV divided by BP. Okay, now let me just clean the space so that you can see what we are looking for. All right, now we want the value for RV and then divided by VM. Now we can see that we're having another triangle which is VW is parallel to PQ, meaning this side here of PR is equals to this side of RQ in terms of ratio. Then we are going to equate that so that we can be able to solve it. Yes, of course, we said RV divided by VP equals to RW. You can see where's RW is this one, which is 4, divided by WQ, which is this one, which is 5. Then our answer is 4 over 5. So that's the answer, or that is the value for RV over VP. Then the line parallel to one side of a triangle. You always write that. If you conclude this side is equal to this side in terms of ratio, you always conclude with that reason. That's a line parallel to one side of a triangle. The next question, hence determine the numerical value of X. Where is X? All right, now we're looking for this X now. We're looking for that X, and then let's see on how do we do that. Now, because if you remember very well, we have determined or expressed this VR in terms of X. It was 9 minus X. Now, we are going to be using the same ratio here on number 3, VR. Now, for VR, now we're going to substitute it with 9 over X, 9 minus X. Sorry, 9 minus X. And then VP, then of course, VP, we have what? We have this X plus this 3, which is X plus 3, equals to what? 4 over 3. Because we have proved that the value of RV divided by VP is equals to 4 over 5. Then this is what we did. Then from there, we then cross multiply. You can see that then you just cross multiply, then you then open the bracket with this 5. 5 times 9 is 45. 5 times negative X is negative 5X. And then next to the right hand side, we say 4 times 3 is 12, and then 4 times X is 4X. Then because now we are calculating for X, then we're going to transpose this X this side. Then that's why we are having now negative 5X minus 4X. It gives us negative 9X. Then of course for these values there, 12 minus 45 is going to give us negative 30. Now 30, 33. Then you're going to divide both sides, then it's going to give us XS 11 over 3. So the value of X is 11 over 3. Okay. All right. Thank you very much for spending time with me on this lesson. You can take this activity and then try to test yourself as whether you understand all the theorems that we touched on this lesson. The theorems for grade 11 as well as the question for grade 12 under similarity and proportionality theorems. And then this is going to be the last part of our lesson for today. And then, boys and girls, this is the message for you, which says, I have seen your struggles and dedication for exam, and then please do not stress, take time and do your best. I believe that you will do very well in your coming exams, and then all the best for your exams. Have a wonderful Saturday or weekend. Thank you very much.